In this lesson, we're going to discuss port security. Port security is a common security feature found on network switches that allows administrators to restrict which devices can connect to a specific port based on their network interface card's MAC address. By enabling port security, your organization can prevent any unauthorized devices from accessing your network, which will help to increase the security of our given networks. Now, our network switches are networking devices that are going to operate at layer 2 of the OSI model. These devices make traffic switching decisions based upon the MAC address of the sending and receiving devices through a process called transparent bridging. Now, unlike hubs, which are an older type of networking device, switches are going to use intelligence to prevent collisions on your network. Each port on a switch is going to be inside of its own collision domain, and this allows the switch ports to operate in full duplex mode. This means that a port can both send and receive data at the same time without a negative effect on the traffic being carried. This also increases the security of the traffic being carried because only the devices being addressed by the traffic are going to receive a copy of that data. A switch remembers which devices are connected to which switch port based on their MAC addresses, and this way they can forward traffic only to the ports that are involved inside of a particular conversation. In the past, our hubs would simply rebroadcast every piece of traffic out to every single switch port, but switches broadcast traffic to only the intended receiver, which makes switches much more efficient and more secure than a hub. All of these MAC addresses and the ports with which they are associated are going to be stored inside of our switch's CAM table. Now, the CAM table is spelled CAM, and this stands for the Content Addressable Memory Table, and it's going to be used to store information about the MAC addresses that are available on any given port of the switch. However, attackers have learned a technique called MAC flooding, which essentially causes a MAC address overflow to occur inside of that CAM table by flooding the switch with a bunch of randomized MAC addresses. When this happens, it can overfill the CAM table and the switch will simply fail open and simply begin to act like a hub. So, your switch begins to rebroadcast all of its traffic out to every single port on the switch, and now that switch has lost its security advantage. To prevent this type of an attack, we should enable port security or MAC filtering on the switch ports, which are also known as interfaces. Now, by default, Cisco switches will have all their interfaces turned on, and this makes it easier and more convenient to add new switches into our network. But this practice is not considered to be very secure. For example, if we have a network jack that's sitting in a common room, like our conference room or a lobby of our office building, how are we going to prevent unknown devices from plugging in a Cat5e cable into it and gaining immediate access to everything inside of our network? Well, to help solve this problem, manufacturers provide a security feature known as port security. Now, port security allows a network administrator to associate a specific MAC address from a device to a specific interface. For example, we can restrict the network jack in the lobby to only accept MAC addresses from laptops that have been pre-approved by our network administrators for that use. Any other device that tries to plug into that switch port is going to be rejected and not given logical access to your network. Now, port security can be a very lengthy process to set up because we have to know each and every MAC address that we're going to want to connect to that individual switch port. To make this a little bit easier, most manufacturers allow us to set up what is known as a sticky MAC. Now, with sticky MACs, also called persistent MAC learning, we can enable an interface to dynamically associate the first MAC address that is connected to that switch port as an authorized MAC address in terms of port security, and this can then prevent access to any other MAC addresses that try to connect to that switch port. While these port security features are really good, they are not a silver bullet that will stop every attack. To overcome them, attackers have created lots of different ways to bypass this MAC filtering that's used inside of port security by resetting the MAC address of their own network interface cards to a known good MAC address on your pre-approved list. This type of MAC spoofing will allow them to easily connect to your network, and so for this reason, an organization needs to really use a more in-depth defensive plan, like one that includes 802.1x authentication, the use of the Extensible Authentication Protocol or EAP, and other kinds of security measures to provide additional layers of security to validate the devices as they're attempting to connect to a given network. Now, 802.1x authentication is going to rely on the 802.1x protocol. The 802.1x protocol is a standardized framework that's going to be used for port-based authentication for both our wired and wireless networks. Because 802.1x is just the framework, though, it's going to utilize other mechanisms to do the actual authentication process, like using Radius or TACUS+. Now, for 802.1x authentication to work, it's going to require the use of 3 different roles: the supplicant, the authenticator, and the authentication service. The first of these is known as the supplicant, and this is the device or the user that's requesting access to your network. The second one we have is the authenticator, and this is the device through which the supplicant is attempting to access the network, such as a network switch, a wireless access point, or a VPN concentrator. The third one we have is an authentication server, which is going to be our centralized device that performs the authentication, and this is usually going to be configured as a Radius or Tachus Plus server. Now, while Radius and Tachus Plus can both perform the role of the authenticator, we have to determine which one of these is going to be best for our particular enterprise network. Radius is a cross-platform protocol, but Tachus Plus is only used by Cisco proprietary devices. Tachus Plus is going to be a little bit slower in operations because it relies on TCP for its transport protocol, but this does add additional security and independently conducts authentication, authorization, and the accounting process by using Tachus Plus. Tachus Plus also supports all networking protocols, but Radius doesn't support the Remote Access Protocol, NetBIOS Frame Protocol, or X.25 PAD connections. Overall, I find that Tachus Plus is an excellent choice if we're only using Cisco devices across our entire network. Otherwise, I'll usually opt for using Radius in my 802.1x implementations when I have a mixed network infrastructure that contains Cisco and other networking devices. Now, when you're designing your security architecture for your enterprise network, you should definitely be using 802.1x as part of your defenses. Using 802.1x is one of the best protections that you can add to your internal network to prevent rogue devices from gaining access to our organization's devices and resources. Because it provides port-based authentication, anything that connects to a switch or a wireless access point will be required to present itself for authentication using that 802.1x protocol prior to gaining access to the entire network. The 802.1x framework and protocol can also be used to encapsulate EAP or the Extensible Authentication Protocol too. Now, the Extensible Authentication Protocol, also known as EAP, is not a single protocol by itself, but instead it is a framework in a series of protocols that allows for the numerous different ways for us to conduct authentication, including things like the use of simple passwords, the use of digital certificates, and the use of a public key infrastructure. There are lots of different variants of EAP, including EAP MD5, EAP TLS, EAP TTLS, EAP FAST, PEAP, and EAP LEAP. Now let's take a look at these 6 variants of EAP to understand how they're different. First, we have EAP MD5. Now EAP MD5 is a variant of EAP that utilizes simple passwords and the challenge handshake authentication process to provide remote access authentication. If you're using this method of EAP MD5, you're going to have to ensure that you're using a long, strong, and complex password in order for you to maintain the security of your system. EAP MD5 is considered to be a one-way authentication process, and it's not going to provide mutual authentication like some of the other versions of EAP will. Second, we have EAP TLS. Now, EAP TLS is a form of EAP that uses public key infrastructure with a digital certificate being installed on both your client and the server as a form of authentication. This makes it immune to password-based attacks because neither side is going to use a password, and instead, they're both using digital certificates to identify themselves. This is considered a form of mutual authentication because both devices, the client and the server, each is going to go through and authenticate the other one as part of the connection process. The third one we have is known as EAP TTLS. Now, EAP TTLS is another variant of EAP, and this one requires a digital certificate on your server, but not on your client. Instead, the client is going to use a password for its part of the authentication process, which makes it a little bit more secure than the traditional EAP MD5, which only uses passwords on both sides, but it is considered to be less secure than EAP TLS because now we're only using one digital certificate and one password instead of using both digital certificates on the client and the server. Fourth, we have EAP Fast. Now, EAP Fast is another variant of EAP, and the FAST stands for the Flexible Authentication via Secure Tunneling, and this uses a protected access credential instead of a certificate to establish mutual authentication between two devices. Fifth, we have the EAP variant known as PEAP, or the Protected EAP. Now, the Protected EAP variant is going to support mutual authentication by using a server certificate and your Microsoft Active Directory database in order to authenticate a password from your given client. Sixth, we have LEAP. Now, up to this point, the other 5 versions of EAP are all considered to be cross-platform. But with LEAP, we are talking about a proprietary protocol that was developed by Cisco, and this stands for the Lightweight EAP. Now, because it's proprietary, it's only going to work on Cisco-based devices. So unless you have all Cisco routers and switches in your network, you should really stick with one of the other types of EAP that we just discussed inside of your network configuration because it will work across all of your devices and not just Cisco devices. So remember, Port security is a network switch feature that's going to restrict which devices can connect to specific ports based on their MAC addresses. 802.1x is an IEEE standard for network access control that's going to authenticate devices based on their capabilities and is primarily used at the data link layer, which is layer 2 of the OSI model. The Extensible Authentication Protocol, or EAP, is considered to be a flexible authentication framework that's used in conjunction with 802.1x to support multiple authentication methods using either EAP MD5, EAP TLS, EAP TTLS, EAP Fast, PEAP, or EAP Leap. By integrating port security with 802.1x and EAP, our organizations can really increase their network security by ensuring that only authenticated and authorized devices can gain access to our most critical and sensitive resources.